So in this problem, we have two vectors, A and B, and they are given in azimuth and transverse angle notation. What I want to do is add vector A and vector B. What we never want to do is do any addition or really work with any vectors in azimuth and transverse angle notation. So the very first thing I do whenever I see force vectors defined to me in this type of notation, I take it and I put it in rectangular coordinates. So just to summarize, we have A and we have B. For A, the azimuth angle phi is 25 degrees. Azimuth angle for B is 50 degrees. The transverse angle from A is 45 degrees. And an important thing to note, for A, it's measured to the z-axis. For B, it's measured to the x-axis. So this is 45 degrees. And I'm going to make a little notation here at the bottom. Sub z, this theta is equal to 20 degrees. This is from x. With those things, we can start calculating the rectangular coordinates for each of these. It's nice to note that the way I have this drawn, we have these projections of the vector down onto the zx plane. I generally call this prime. So down here at this bottom, this length here is A prime, and this is B prime. And we're going to need to use these to get the x and z rectangular components. That's the first thing I calculate. So if I do A prime is equal to A, which is 100 times the cosine of 90 minus phi. So this will be 90 minus 25. And it will be equal to 42.26. The rectangular component in the y just uses the azimuth angle. This is AY times 100 cosine of 25, which equals 90.63. AX is equal to A prime, which is 42.26, times the cosine of 90 minus the transverse angle, which is 45. And we had to do 90 minus 45 because the transverse angle is measured to the z-axis, and we want to know what the rectangular component in the x-axis is. So it's going to be 90 minus the angle to the x-axis. That equals 29.88. If I do AZ, it equals 42.26 cosine of 45, which equals 29.8. I'm going to go through and do the exact same things for the B vector. B prime equals B, which is 85, cosine of 90 minus 50, which equals 65.1. By equals 85 cosine of the azimuth angle theta, phi, which is 50. This equals 54.64. Bx equals 65.1 B prime times the cosine of theta b. And since for vector b, The transverse angle is measured to the x-axis. We don't need to do 90 minus here. We can just put that in here and say 20. This equals 61.17. And if we do BZ, it's equal to 65.1 cosine of 90 minus 20. And that is 22.7 or 22.27. Then, to get everything and add it together, we just add like things. We add AX to BX, AY to BY, and AZ to BZ, which will be 29.88 plus 61.17 I plus 90.63 plus 54.64 J plus 29.88 plus 22.27 K. That gives us an IJK notation, 91.05 I plus 145.27 J plus 52.15 K. And if I ever ask you just to add together two vectors and I don't tell you how I want the result, always just give it in rectangular components or I, J, and K notation. Don't take the time to figure out what the resultant is or calculate the angles that you need. Just easier and more useful to keep it in I, J, and K notation. And the only reason I would ask you to move it out of this is to understand if you understand how to get the resultant and find the angle.